Hi, I'm Polita, and I'm an engineer at Snowflake. Today, I'm going to talk about Iceberg tables, how to use them, how we built them, and give you a sneak peek into what we're building next. I'm excited that you're here. I have a Snowflake and Spark demo I can't wait to show you. Let's get started. Okay, so a lot of businesses are using data lakes to store their data, and they want to get insights from that data. Table formats define the shape of the data and allow tools to read data in consistent ways. Table formats also allow multiple tools to operate on data in storage in a transactional way. Apache Iceberg defines an open table format for use in data lake architectures with large analytic data sets. Iceberg addresses consistency issues with previous table formats. It offers features such as schema evolution, time travel, and safe concurrency. And because it's open, several processing engines and tools can coexist and bring insights to a dataset. Iceberg was originally contributed to the Apache Software Foundation by Netflix. Today, it has many contributors and is gaining a lot of adoption. Iceberg offers customers a strong community and breadth of tools. It addresses gaps from previous solutions that made analytics over data lakes difficult. Iceberg's strong ecosystem means you can find the tools you need for your data pipeline. Iceberg is gaining popularity and adoption very quickly, which is driving innovation and a breadth of new contributors and tools. If you need insights from your data lake from several tools and pipelines, Iceberg may be the best approach. Snowflake offers several options you'll need to decide between when loading your data. If you only want to query your data, but not perform DMLs on the data, external tables on the right side of this slide offer an easy way to query, share, and govern data. And external tables support lots of different storage providers through S3 Compat. External tables support several formats, one of which is Iceberg. The left side offers options for tables where you can perform full DML on your data to change and evolve it. If your data requires open formats, Iceberg tables in Snowflake might be the right path for you. Today, I'm going to talk mainly about that dark blue box. Iceberg tables managed in Snowflake are fast, but beyond performance benefits, there are a lot of platform capabilities Snowflake brings to open formats. Iceberg tables will offer the full set of Snowflake features, including data masking and row access policies, tagging, multi-table transactions, streams and tasks, cloning, sharing, role-based access control, replication, automatic data loading, and programmability with Snowpark and external functions. Now I want to show you Iceberg tables in action. For this demo, we'll use S3 as our customer managed storage, but of course, you can choose Azure Blob Storage or GCS as well. I'm going to play the role of a data engineer at a manufacturing company collecting data from water sensors. Pipelines are landing data in S3. In the past, teams have used Apache Spark to access that data. For mission-critical workloads, my team deployed Snowflake and loves it for its governance capabilities, elasticity, low maintenance, and fast query engine. We're working on onboarding more use cases to Snowflake. We want the platform and management capabilities from Snowflake, but we don't want to disrupt Spark workloads running those tables in S3. We'll create Iceberg tables in Snowflake to keep the data stored in one of our S3 buckets, so Spark can also access them. As part of a new project, we are ingesting new sensor datasets from Sensor 2. We standardized on Iceberg as the table format for our data lake. With Snowflake now supporting Iceberg table formats, we will ingest the new Sensor 2 dataset directly into Snowflake managed Iceberg tables in Parquet format on S3 under our control. Let's take a look at how that works. So to create my sensor data Iceberg table, first I need to set up the storage location where the Iceberg table will persist its Parquet and metadata files. I'm creating an external volume with locations in both East US and West US. Because my deployment is in West US, the external volume will automatically choose that location and ensure it has all the storage privileges it needs. Now I can create our Iceberg table with sensor data. The Iceberg keyword lets Snowflake know that I want this table to store its data in Parquet with Iceberg metadata using my external volume. These sensors are testing water, so my table has pH, potability, hardness, and other metrics for water. Next, I'll insert data into my table using data in an external table over Parquet files. I'm going to insert 500 batches of data, which will give me a large amount of data to work with. My insert finished, and I inserted 1.6 million rows of data. Now that I have my sensor data in my Snowflake managed table, I want to ensure that Spark can read it too, because my company has existing tools using Spark to read that sensor data. I now need an Iceberg snapshot of my data for our Spark table. I'll ask Snowflake to generate an Iceberg snapshot using get Iceberg table information. The snapshot metadata will live near the Parquet data on my external volume. I'm also going to copy the table path for use later. Let's look at the S3 bucket where the Parquet data and metadata for my Iceberg table live. When I refresh, I can see the Parquet data and metadata. Inside the metadata folder are my manifest lists and manifest files. I'm using Iceberg because I also need to read my sensor data in other tools. I have an EMR cluster with Spark running, and I use it to run certain processing jobs on the data. It's important that I ensure the same data is in Snowflake and in my Spark jobs. So I'll reconfirm the number of rows of data in Snowflake. Okay, remember this number ending in 724 because I'll want to compare that to the row count when I insert the data using Spark. I need to load the data in Spark in my EMR cluster. I can point my Spark load command to the metadata we just generated for my Iceberg table. And then I'm going to create a sensor sample view. Then I'll count the rows to ensure I've loaded all the data. I've now loaded 1.6 million rows, and notice it's exactly the same number of rows, ending in 724. Okay, a day later, I have new batches of water sensor data to insert from the raw Parquet files. I've now inserted an additional 330,876 rows. Let's count the total rows. I now have over 1.9 million records. And again, let's take note of the count ending in 600. I'll also generate a new Iceberg snapshot that includes my new rows. I'll need the metadata path for my Spark load command again. This time, when I load the new water sensor data in Spark, I'll create a data frame from the loaded data, then count the rows in the data frame. The number of rows matches our number, ending in 600. Now I can use my data frame to run some of my Spark jobs. I have a Spark job that inspects the sensor data to ensure sensors are working correctly and producing consistent data. I can call it with the data frame, which uses the very same data files my Iceberg table generated. My routine is showing me which sensors are producing good data and which need to be inspected by our field team. Let's take a look at just 10 rows of data. When I run the same query in Spark, I get the same 10 rows and columns, which is what I'd expect. Let's give it a try. But now I need to change the columns of our sensor data a bit. Our sensor IDs are now sensor numbers, and I want the column name to reflect that. We no longer use the correlation ID, so I'm going to drop that column. And now I have a new column, is active, which indicates whether a sensor was active. Once I've made the changes to my table schema, I can confirm by selecting a few rows and seeing the new columns. I'll generate a new Iceberg snapshot for that table, and we'll include the new schema so my Spark jobs can see it too. When I load the data and select a few rows now, I should see my new schema reflected in my Spark data. I can see we use sensor num instead of sensor ID. Correlation ID is gone, and we now have is active. With Iceberg Tables, I was able to manage my data using the power of Snowflake and also integrate with my existing Spark jobs to read the same data. As my schema evolved, I was able to easily make changes to my Iceberg table, which was immediately available to my Spark jobs. And both Snowflake and Spark worked against a single copy of the data in storage managed by my IT team. Now that we've created Iceberg tables, consumption of the Iceberg tables is easy. We can continue to use the tools we have in the past. We make minor modifications to the existing jobs to connect to the Snowflake managed Iceberg tables. The rest of our jobs stays the same. Now that we've gotten to see what Iceberg tables can do, let's talk about how they do it. As you saw, Iceberg tables are fast. Let me show you how we built Iceberg tables with performance on par with other Snowflake tables. Iceberg tables are just like other Snowflake tables, but they happen to persist their data in Parquet along with Iceberg metadata on customers' storage. Snowflake maintains our own metadata for Iceberg tables, the blue boxes. We also generate Iceberg metadata in yellow using our metadata. Both our internal metadata and the Iceberg metadata point to Parquet data files in customer managed storage in purple. Maintaining our own metadata allows us to leverage 10 years of Snowflake optimizations and innovations, including pruning, file caching, query parallelization, concurrency, and clustering. Snowflake performance monitoring and profiling tools just work with Iceberg tables. And since Iceberg tables are so similar to other Snowflake tables, Snowflake can bring its wide feature set to Iceberg tables with very few changes to our service. Within Snowflake, an Iceberg table is just like any other Snowflake table. Of course, the speed of accessing your data files in storage can significantly affect the overall performance of your queries. So it's really important that calls to storage have the lowest possible latency. When you create your external volume, Snowflake enforces that the storage for your table lives in the same cloud region as your Snowflake account, then ensures it has the privileges it needs to access data files. Multi-table transactions, the ability to transactionally make changes to related data that spans tables, have been pivotal to Snowflake for a long time. This is a key ability that many engines don't support, which can make managing related data really painful. Snowflake handles transactionality and rollback across all the commands seamlessly. Now I want to show you what we're working on. These features are coming in the next few months. If you already have Iceberg data, we're building support to migrate your Iceberg snapshots to Iceberg tables managed in Snowflake. Your new Iceberg table will use your existing Parquet data files instead of rewriting them, which means lower storage costs for you. Using the migrate snapshot location syntax in blue, you can specify a snapshot to migrate data when you create your Iceberg table. New data will be written into new Parquet files in your external volume. Once you've migrated the data into your Iceberg table, it becomes native data, and it can leverage the Snowflake features that any other table can, and other tools can still access your migrated files. We're working on improved compatibility with other tools, such as Apache Spark, Flink, and Trino. Snowflake will offer a Metastore API that will allow other tools to query and make changes to data in Iceberg Tables managed by Snowflake. We're also ensuring smooth metadata and type compatibility with the Parquet data and snapshots generated by popular Iceberg tools. Parquet supports the complex types map, list, and struct. Soon, you'll be able to declare an Iceberg table that will persist data in these complex types, but allow you to access the data in a natural way in Snowflake. For instance, when declaring your Iceberg table, your columns can be of type struct, array, or map, and include the member types in blue on the right. When you insert data, you can use type construction syntax to assemble your types. And when extracting values, an appropriately typed data will be returned instead of a variant. These examples here are simple, but this syntax can be really powerful in constructing and extracting data into types you can work with. Thanks for taking the time to dive a little deeper into Snowflake's Iceberg table support. If you haven't yet, talk with your account team to sign up for the preview, give it a try, and send us your feedback. For more information about Iceberg and developer resources, go to developers.snowflake.com. To engage with the Snowflake community, go to community.snowflake.com. Thanks for joining me. For more content like this, press like and subscribe. See you next time.
Thank you. Good evening, everybody.
Welcome to Community Update. I'm Elsa Mayer.
And I'm Leith Darausha. Last week, one of our Snowflake data superheroes started developing actual super strength. She hopes to soon use this newfound super strength to break data silos all over the globe, without unintentionally breaking her keyboard.
This just in. Presenters at user groups are becoming overnight celebrities. That's right, folks. They've been featured on page 6. They're trending on TMZ. And it looks like there might even be an Emmy category next year for Best User Group Presentation. What data model could have predicted that?
As many of you have seen, Snowflake recently launched forums in the Data Heroes community, where you can ask technical questions and get quick answers from expert Snowflake users. Here to share tips on how to participate in the forums is our top forum contributor, Dan, aka Danny Data.
Woo! Thanks, Leif. It's great to be here. I've developed a whole philosophy and a lifestyle that will set me up for success in the forums. Just like any performance athlete, I follow a rigorous training every day to ensure I'm always the first to respond to a new question. I get at least 12 hours of sleep, follow a strict diet, and I train my wrist and fingers for maximum speed on the keyboard.
That's very impressive, Danny. What about once you're actually in the forums? Do you have any pointers for community members who might be following your lead?
Of course. It's just as much about the mental preparation as it is about the physical preparation. Every day, I meditate for an hour, repeating my mantra, no question left unsolved. And every day, I also read Snowflake, the definitive guide cover to cover to make sure I stay sharp.
That's great, Danny, but I hate to break it to you. You do realize that it's much easier than that. You really don't need to do anything but stay up to date with Snowflake and keep building. It really only takes about 10 to 15 minutes a day to contribute to the community. Yeah.
Wait, what? Let me get this straight. No training, no routine.
Yep.
I'm fine. Sorry. You know what? This is great. I feel liberated. You know, I need to go tell the community about this.
Danny Data, everyone.
For Community Update, I'm Leith Darausha.
And I'm Elsa Mayer.
Good night.